Well, welcome back, everybody, to this series of interviews for our enterprise computing class. Today, we are fortunate enough to be joined by Ed Holden, one of the faculty members at RIT, who teaches in the area that we're going to talk about today. So, thank you very much for joining us, Ed.
Oh, you're welcome. Glad to be here.
All right, very good. So, maybe to get started, could you tell the folks a little bit about you and some of the things that you teach and do around here?
All right. Well, let's see. I've been in the computer industry since long before most people were born. I started probably in the 1960s, and I've worked long before even there were undergraduate computer science programs, and so I have, I've seen pretty much the spectrum of computing. The first large computer that I worked on, I put large in quotes here, had a whopping 8K of memory for me to use. So I think from that standpoint, can you imagine that? But from that standpoint, I've really been in just about all phases of the IT business. And I have, worked with, mainframe computers. I've worked with servers. I've worked with websites and the development really of enterprise applications for primarily for a Fortune 50 company. Currently, I left industry about 14 years ago, and I'm now an associate professor here at RIT, and I teach primarily database management and programming, and a few other things, but that's the primary area. So database management, data warehousing, a lot of things that the enterprise would be concerned about. So it's kind of, I actually even belonged to a department one time. It was called enterprise computing. So I've been just about everywhere, and I've been in management of IT as well, which is an interesting place to be when companies are in transition and stuff like that. So I've seen a lot of the IT industry over the last 35, 40 years.
All right, very good. Well, this is the reason that we wanted to talk to you today. I think you're a perfect fit for some of the topics for the class, and especially when we start talking about the scaling stuff. Mm-hmm. So why don't we start with databases? Could you tell us, for the folks that are trying to wrap their hands around all of the issues associated with enterprise computing, certainly databases come to mind. Could you describe in whatever way you want to what a database is and some of the reasons why they're so important to us?
All right. Well, in its very basic definition, a database is primarily just a repository of data. All right. Databases are key to any type of enterprise computing. Primarily, without data, there's no need for networks, for programs, for websites, for anything else. There are no websites in the world today that don't rely on some sort of a source, for data. If you think Amazon or government databases or whatever, whatever they happen to be, all of the scandals, that we've seen in the news, involve the theft of data. It's not, oh, somebody stole a page on a website or anything. When we read about Snowden or we read about the recent Target problem, it's the theft of data, and so data is really key to to anything that we do in the IT business, and I think that's one thing that we need to be concerned about. In our current environments, I think, and this has been a slow evolution, having a more centralized repository of data, and that doesn't necessarily mean a database, but a more centralized repository of data that can be utilized and analyzed and served to other people throughout the enterprise is becoming a critical aspect, for any business. The other day, it used to be, I remember when chief information officers, CIOs, used to be kind of relegated to the financial organization or some other organization. Today, and in fact, I saw an article about this the other day in one of the trade rags about CIOs are now becoming an important resource for CEOs. And it's primarily because businesses are beginning to realize that they can't survive without being able to, to have data readily available to them, whether it's data about their customers, data about their competitors, data about how their business is operating, whether it's manufacturing or what it is. And also the integration of that data has become much more important. All of this push toward enterprise resource planning systems like ERP systems, whether it's SAP or BON or Oracle applications or PeopleSoft or whatever it happens to be, is really a push toward the centralization of data. They all rely on centralized repositories of data. So, for example, in an SAP system, when a customer places an order, okay, that order is really presented to the company. Okay, and it used to be it would sit in some little storage place where later on it would get passed on to manufacturing or to a supplier or whatever. But as part of the current ERP thinking, that order now is instantly available to financial people, to manufacturing, to suppliers, to whoever needs the information on that order in order to fulfill that order. And so I think it becomes even more evident today that the problem prior to the ERP systems was really a lack of integration of data. And so that's kind of where we have come, I think, from years ago where everybody worked in silos and everybody had individual roles, even within IT organizations. Today, there's more of an integration of of the data throughout the company, and that's data internally to the company, but also data that needs to be exposed outside the company, and also from a security standpoint, the protection of that data, so that only those who need the data can get the data. Excuse me. And so I think that's kind of the way that I visualize databases, and the way I visualize data within a company, is it's a resource for the company.
That's a really good explanation. Thank you. So we're talking to you in the context of an enterprise computing class, and you mentioned things like enterprise resource planning. When I say the phrase enterprise computing to you, what are some of the things that, as a database sort of person, jump to your mind?
Well, the first thing that jumps, of course, is the database, right? But enterprise computing, to me, is a buzzword like any other buzzword in the IT business, whether it's cloud computing or database management or database proliferation. All of these are kind of buzzwords. And Larry Ellison, who's the CEO of Oracle.
The Oracle of Oracle, as they say.
Is what? The Oracle of Oracle, right. One of the things about Larry is that he was giving a lecture on cloud computing one time, and one of the things he says that, and I won't have this quote exactly right, but he said, cloud computing is the latest buzzword. He says, I don't know what we would do any differently than we're already doing today. But if cloud computing is the buzzword, we will do cloud computing. If Orange was the new fashion, we'll make Orange databases. And he said, in any case, he says, we will conform to whatever anybody's conception is of cloud computing. But when I look at enterprise computing, I think primarily of larger businesses, okay? Although I think the same concepts apply to small and medium-sized businesses as well. But cloud or enterprise computing, I think is primarily been aimed at larger businesses because larger businesses have bigger problems with the proliferation of areas where data is isolated. And I think and where people maybe don't talk to each other or know each other. So when I look at enterprise computing, I look at it as trying to integrate larger businesses so that they can communicate more effectively and operate more effectively for their customers and employees.
All right, very good. So that is one of the big issues that we've been talking about in our class, is the issue of scaling, whether it's the network part of the design, whether it's your server architecture, or it's your data center. Really what we're talking about here is scaling this up to a much larger sort of architecture. Mm-hmm. So with that being said, what are some of the scaling issues that we run into when we start talking about data and databases? We've got the famous examples of FoxPro and Access databases, and then moving into something like Oracle, which is a big change in complexity and things like that. But what are some of the issues as we scale up data and databases?
Well, I think there are lots of issues, and the problem is sometimes we have a tendency to look at scaling within our own areas of expertise. So if it happens to be database, scaling is a database problem. If you happen to be a networking person, scaling is a network issue. If you happen to be a systems administrator, it's the servers that are the problem. Okay, so I think what we have to realize is that scaling is an enterprise problem. It's a problem that exists in all different types of technologies, whether it's somebody writing programs or developing websites, or whether in security for that matter, because the bigger you get, the bigger target you are. Okay, so I think all of the areas of the enterprise are important. From a database perspective, when I look at things like Access, which serves, I think, a very valuable role in a lot of companies. Access is what people who've had me for a database class will hear me call it a pretend database. Okay, and because I look at databases as having a couple of characteristics. They have to be accessible for multi-users. They have to be a standard repository of data, and they have to be scalable from smaller to large. Okay. Now there are a number. I place database products into categories. Access is in the lowest category. Serves great for single user environments, but it's nothing I would ever develop an enterprise application in. Okay, so that would be the first thing. Then if I go to the next tier, it would be things like MySQL, Postgres, database management systems like that, which I call kind of pseudo-enterprise databases. They will serve very, very well in a lot of environments. For example, a lot of websites are supported using MySQL. We talk about the LAMP stack all the time, which includes, MySQL. So that can be a valuable tool. When we start talking about Oracle, and I would also put Microsoft SQL Server and IBM's DB2 into that category, we're starting to talk about truly scalable database management systems. And these particular systems require heavy utilization of networks, because very rarely does anybody log directly into the database to use it. We're talking about heavy-duty servers or mainframes. We don't want to throw mainframes out of the mix. They're becoming much more valuable, particularly as we move into the area of cloud computing. Mm-hmm. And I think that, but as we look at databases, we want to look at, if you are in a medium to large company, we want to look at things like Oracle and SQL Server because they will scale as large as you want them to scale. And so I think that that's, when I think about scalable and large databases, I think about SQL Server from Microsoft, DB2 from IBM, and Oracle from Oracle. And those are for structured data. Those are the databases that I would use.
All right, very good. It also sounds like you're making a distinction between what we might call an enterprise database and a database management system.
Well, to a degree, a database management system is just simply a tool. All right, and so the data there are people who build databases without a database management system. I don't know that that's a good idea because you're really reinventing a lot of what has been built into a database product. With all the security, with all of the things that are in the database management system. But to me, when you're building a database, in its purest sense, it is just simply a repository. Excuse me, a repository of data that is available to an enterprise.
Usually organized in table format, right?
Yes, right. Organized in table format and in an understandable format, so that application developers can get the data from the database, for the user. And I think that is, to me anyway, one of the one of the key things about a database. Now, normally that's going to involve a database management system, and normally that's going to involve, one of three: Oracle, Microsoft SQL Server, or DB2. There are others, but to me those are the big ones.
All right. You mentioned something earlier that I don't want to get too sidetracked here, but you sort of alluded to vast repositories of data that might not be part of your database, that might not be organized in table format, but still require the storage management and maybe access to for data mining. Were you thinking about something in particular?
Nothing in particular, but just from large companies that I have seen, often have pockets of repositories of data that are not easily accessible. And quite often this has come from, just simply the way they've been developed over the years. They have, there are still databases and applications that have been developed back in the 70s and 80s. I know that sounds crazy, but, when we're teaching databases here, I think sometimes people get the idea that everything is very well organized, and it's not, particularly when you get into larger companies. To give you an example, one of the applications that I developed in the 1970s just went out of production 2 years ago. Okay, and this was not it was a database in a data repository, but it was not easily accessible by any stretch of the imagination. And I think this is when we get into a company, we begin to see these things and people start feeding data from one application to another, rather than just saying, here is the data, we can make it available to you. Primarily because it's not available in a database. It might be available in some other repository of data. It could be just an indexed database. It could be indexed files. It could be things we don't talk much about, but ISAM and VSAM. Okay, two products of the 1960s probably, or 1970s, that would, where, data has been made, where data has been stored, and no company has wanted to pay the money to convert them into more of an accessible or a database environment. And so that's kind of what I look at when I say that there are kind of these islands in large companies. For a newer company, that's going to be less true. Because in a newer company, people have come at it from a different perspective.
Okay.
Okay, that's, I don't know whether that's too confusing or not. But.
No, I think that's a great example. When I was working for the pharmaceutical industry, we had a bunch of machines that took telemetry and took readings, and they would just pile all of these into a spreadsheet format, with no headers, no indication of what the fields are, but it was the data that you needed to access, and so you would have to pore over them and generate reports from this stuff, and nobody knew how many machines or how long the data had been there. It was just sort of an interesting collection of numbers.
Yeah, and it's scary sometimes.
Yeah.
You know, what people rely on for information. You know, I like to tell a story that one time, and this probably was in the 1980s. Okay, your students won't be happy to hear about the 1980s, but probably in the...
I will. It's okay.
It's okay. It's okay. I'll talk to you. But I remember one time that we had there was an accounting term called accruals, and I don't know whether, you know, you need to know something about your business. Okay, accounting is a good course for students to take. But in accounting, there is this idea of accruals. So, for example, if I pay money today for something, the business may not have earned that money yet, and so the money goes into what's called an accrual account. So if you were to buy, say, a service program on a washing machine, I don't know, the company that sold that, or a car, a warranty, extended warranty on a car, the company has not earned all of that money yet. The money goes into an accrual, and they take a little bit out each month, and that's what goes into their earnings. All right, so that's your accounting lesson for the day. In one of the applications that I had to calculate accruals like that every month. So we would bill customers, and this was the amount we earned, and this was the amount we accrued. Okay? About once a year, the number that the system put out was wrong, and nobody really understood why. The accountant knew what to fudge into the system to make it work, but it was wrong about once a year. We didn't know why. There didn't seem to be a pattern. So anyway, I spent a great deal of time and I solved the problem. And I told one of my employees, now this is in the 1980s, I said, Susie, I don't want you to ever change this program. We have finally figured out how it works. And the program had been written in the 60s. We finally figured out how the program worked. I don't want any changes to this program. Now, if we flash forward to 2010, Susie's current supervisor, Susie had retired and came back to work on this particular application. Susie's current supervisor came up to her and said, you know, we need to make some changes to this build accrual program. And she said, oh no, I can't make changes to that. And he said, no, you don't understand. We need a change for this reason. And she went all through it. She says, I'm not changing that program. Because back in the 1980s, her former supervisor, namely me, had said, never make changes to that program. And you know what? They didn't make any changes to the program. It was just kind of, I always find that amusing. But that is the type of thing that you run into in an enterprise. Sometimes the people who have developed it, like the people in the 1960s, are long gone. And people have no idea how it works. It runs into a problem, you get it figured out, and then for the next 20 years, nobody wants to figure it out again. And that's the problem we run into when this data sits in a repository and applications massage the data without anybody understanding how the whole thing works. And I think that that's really kind of an area that you run into with enterprise computing. It's not about technology. You know, it's about the practice of pulling things together so that they are resources for people in the company and outside the company to use.
Well, it's interesting that you mentioned people and some of the practices. We've been talking a little bit about network design issues associated with scaling up, and some of the most important things are understanding what people are doing and what things are running on the network, and getting out there and actually doing some research where you have to exchange ideas and talk to human beings. So that's kind of an interesting take there.
Yeah, and and related to that too, you mentioned about what users do with systems. Regardless of what the system is designed to do, users will always figure out different things to do with the system. that the developers and the analysts involved in the systems never realized that they would do. And another application that was developed, which was an online transaction processing system, it turned out that it was so easy to get information out of the system that users stopped using the system that they were supposed to use to find information about customers and started using the newer system to do that, even though the system was not designed to do that. And so because of that, capacity in the system was insufficient. And so in a network, once users realize that they can get more information than they could in the past, or easier information than they could in the past, they're going to overutilize whatever you design.
All right, so let's take just a second. I'll let you get a drink of water here real quick, and
Thanks.
Maybe what we can segue over into what databases concern themselves with, and that's primarily, of course, the data itself. And so could you talk just a little bit maybe about the scaling issues associated with data itself, and then maybe what big data is and why are people so excited about it? We talked last time with Chris Butler over in ITS, who runs a lot of the storage architecture that we have here at RIT, and he talked about the massive increase in capacity on the systems. So maybe we could talk a little bit about that here.
Okay. Let's see, we're going to start with that one. The interesting thing, big data is another one of those buzzwords that really does not have a definition. Okay, you can read 10 different definitions of big data and not really know what it's about. But database management systems, or database systems in general, are concerned about the utilization of data. And it's really nothing more than that. So as a database analyst, you have to be concerned about how your users are going to use databases. If you are in a, outside, what is termed big data today, your concern is usually about updating the data. So if you're developing a database that's going to be used with an online transaction processing system, you are concerned about how that data gets updated. So you want to reduce things like redundancy of data. Every time that you have the same piece of data, or two pieces of data that mean the same thing or are duplicates of each other, you have an infinite problem. Because you have to make sure that every application that updates that data also updates it in all places. And that's really almost impossible to do. So that's why in a database class we stress such on this process called normalization, where we are able to get down to data down to its atomic value, so that it is not redundant in any way. Right? And that works very well with online transaction processing systems, like order processing or customer order type systems, because it's extremely useful. That's primarily what they do, is they're doing updates. They also need to be able to retrieve data from that. So you want to have a database, this gets back to the scalability issue, you want to have a database that can operate in a clustered fashion, that can go into larger computers, whether they be large servers or mainframes, that are portable across different development environments, that can be mirrored, and develop a disaster recovery situation. One system that I worked on, an ERP system at one time, the failover time was 30 seconds. If there was a failure here in Rochester, in 30 seconds, the people would be using a computer in another city without losing a beat. Okay, so these are the types of things that you have to be concerned with OLTP systems, and that's about 80% of what we teach people in our programs. The other types of systems, though, when we start talking about big data, may or may not involve databases as such, database management systems. So when we talk about big data is really about the collection and analysis of data. And from there, we're not so concerned about updating the data, but the retrieval and analysis, sorting, searching, applying statistical methods to the data. And that may or may not involve a database management system. Excuse me. So, one example is a data warehouse. Now, a data warehouse does involve a database management system. But redundancy is not one of the key concerns in a data warehouse. And there we develop a data warehouse using something called a star schema. So if you took a data warehousing course or worked in a data warehousing environment, you would find that we're really not concerned about redundancy because the data seldom gets updated. It normally gets loaded and then is retrieved. Big data can play off of a data warehouse. Okay? Now, OLTP systems have the data has a short use in the database. So when you place an order, say with Amazon, that order, Amazon is really only concerned with that order until it's fulfilled. And they will find other ways of storing it after the order is fulfilled. The data warehouse, on the other hand, will be stored forever, whatever the company decides forever means. It may literally mean forever, or it may mean 5 years, 7 years, 10 years. And it's used to do more longitudinal research in terms of the analysis of that data. All right, so that's really what we're looking at there. Now, the other thing, too, is it does not necessarily involve a database. Sometimes the data just comes in a raw form. It may come in an XML format, a JSON format, or just as a stream of data from various sources. This is where things like Hadoop and MapReduce come into the analysis of data. It does not necessarily involve a database management system, but it involves heavy analysis, statistical methods. Data mining courses, for example, are more involved in statistics than they are in the technology of storing your data.
I see. All right. Very good. Very good. Great answer. Thanks, Ed. So we have been talking about a lot of what might be considered the components of enterprise computing. And we're using RIT as sort of our enterprise example. And there's a lot of stuff that goes into it. And we realize that there's a lot of integration and a lot of things that affect other things. Earlier you mentioned, the network impact of having a large Oracle database and users hitting it, and as the number of users hitting the database grows and the size of the database, et cetera, et cetera. What are some of the, in the few minutes that we have left here, what are some of the related issues? What are some of the things that are really important to think about that are related to but not directly part of the database? And then what are some of the challenges associated with running a large enterprise scale database, other than what we've already talked about?
Let's see. I think the biggest challenge with a large enterprise database is the question of availability and appropriate availability. The database in most companies, particularly large companies, if you look at enterprise, is a 24/7 operation. Particularly today, where people, current users of applications, whether it be Amazon or anything like that, like what I call instant gratification, right? So if you go and try to place an order at Amazon, and Amazon happened to be down, okay, that is a lost sale to Amazon. If you walk into the mall and the store tends to be closed, you might wander around for a while and come back to the store. You don't do that with Amazon. You'll go to some other source to buy your product. Amazon has lost the sale. Okay, so availability is key in an enterprise. That database has to be available 24/7. It also has to be available so that the data is accessible in a reasonable amount of time. So it has to be, when you say, I want information about my order, that has to appear within a couple of seconds on the screen, whether it's through a website or through some sort of GUI. But in any case, that is one of the key issues. If that database fails, you need to have a backup and recovery mechanism, and beyond backup and recovery, a disaster recovery mechanism that allows for the application to be back online very, very quickly. Otherwise, it's a loss. So to me, those are the two biggest issues. And it involves availability and availability to the right people. Availability to the right people is the security issue. And again, that's where all the scandals have been recently in the IT industry. But you want only the people who should see data to be able to see data. And I think that is something that's key. You don't want people to be able to hack into your systems. You want to follow the the rule of least privilege, right? You should only be able to see what you need to do your job, only that, and nothing more. Okay, and that goes for you. It also goes for your customers. So security, all of it boils down to availability. Security from the standpoint of being available only to the people who need to see it. Availability, meaning that it is configured in a way that the response time is fast and it's never down, whatever never is. And then finally, that it's available to, that if there is a failure, there is a way to recover fairly quickly.
Very good. All right.
I left something out of it, but
okay.
Just of it anyway.
If we sort of imagine a DBA and the things or the systems that are directly under the control of the DBA is sort of our silo. We talk about silos every now and again.
Yep.
Who are the folks that the database administrator needs to interface with that are outside of his area but become really important to him?
Yeah, the key people, there are two key groups of people. One is the system administrator. The system administrator and the DBA need to be joined at the hip. Okay, primarily because the SA is the one that's responsible for all of that hardware and networks and stuff like that needs to be, and I lump network administration with the system administration. Maybe that's an oversimplification. But the database administrator needs to understand what that person is doing. And the system administrator needs to understand the database administrator. So the database administrator has to design the database in a way that gives the system administrator the flexibility to implement the database in a way that is efficient. If the DBA does a poor job, there's nothing that the SA can do to make it efficient.
All right.
Similarly, and now the other group are the application developers. Because the application developers are the ones that are in touch with the users. So the database administrator, a lot of companies, the application developers don't even create any databases or create any tables. That's all done by the DBA. But he has to do that with input from the application developers. And so he has to be working with them. So those would be the two groups.
All right, great. Thank you. I got one last question for you, Ed. You've been very kind with your time this morning. Do you have any pearls of wisdom for the students as a parting message, or maybe something that, if they're interested in pursuing this sort of line of study, what would be really great for them to look at?
Yeah, I think one of the things that we all do as IT people is we have a tendency to, you mentioned the silos. We tend to think everything rises and sets in our silo. Database people are no different than that. Application developers are no different. System administrators are no different. And that leads to a problem with an industry that is generically called sub-optimization. You know, you can have your particular area operating so efficiently that nobody else can figure out how to work with it. Okay, so it's important, I think, to understand a bit about all of the people that you deal with. I mentioned earlier that, you know, knowing a bit about accounting doesn't hurt. Knowing a bit about marketing doesn't hurt. If you're a system administrator, knowing what DBAs do, knowing what application developers do, knowing what your customers do, I think is very important. So my first thing would be, don't get too stuck in your silo. Make sure that you're looking out to understand what other people in your enterprise are doing. So that's the first thing. If you want to get more involved in database type things, then I think you know, you want to first of all understand what databases are. We didn't even touch on the NoSQL databases or other types of data repositories. All of those are important, okay? But I would take some courses in database, and particularly if you're an SA, who's going to work with the DBAs, I don't understand how you could possibly work without having a DBA course somewhere along the way. No. You need to understand what database administrators do. And for my database administrator people, I always recommend that they take an SA course, all right, because that's important for them to understand. So I would take a basic database course, and I would get some database administration under your belt, so that you understand what a DBA does. And those are available both here at RIT in the IST department, and they're also available to you know, on the outside. You know, Oracle has courses, Microsoft has courses, but it's important to understand, you know, what people outside of your own realm are doing. Otherwise, you can't work with them. You can't design for them, because it's not all about, you know, the area that you're only one piece of it.
Well, I think that's a really good piece of advice, and maybe a really good place to end. Ed, I would like to thank you very much for your time today. We really, really appreciate it, and I'm sure the students are going to get a lot out of this interview. Thank you very much.
Okay, well, good. No, I'm glad to do it. Take care, Bruce.
All right, thanks very much, Ed.
Bye.